So, hello everyone. In this video, I'm going to show you some applications of electrostatics. But before we move on to the applications of electrostatics, we need to first define what is electrostatics. So based on my research on Britannica.com, electrostatics is a study of electromagnetic phenomena that occur when there are no moving charges, meaning it's static. After a static equilibrium has been established, charges reaches their equilibrium position rapidly. Because of the electric force extremely strong, the mathematical method of the electrostatics make it possible to calculate the distribution of the electric field. Now that we are done on the definition of electrostatic, we'll now move on to the application of electrostatics.
The first application of the electrostatic is the Van de Graaff generator. The Van de Graaff generators are not only spectacular devices used to demonstrate high voltage due to static electricity, they are also used for serious research. The first was built by Robert Van de Graaff in 1931, who is named after his surname. Van de Graaff used both smooth and pointed surfaces and conductors and insulators to generate large static charge and hence large voltages. A very large excess charge can be deposited on a sphere because it moves quickly to the outer surface. Practical limits arise because the large electrical fields polarize and eventually ionize surrounding materials, creating free charges that neutralizes excess charge or allow it to escape. Nevertheless, voltage of 15 million volts are well within practical limits. Now let us explain the schematic of Van de Graaff generator. Letter A is the supplies excess positive charge, is a battery pointed conductor, the points of which sprays the charge into a moving insulator belt near the bottom. The pointed conductor, which is the letter B, on the top of the large sphere picks up the charge. The induced electric field at this point is so large that it removes the charge from the belt. This can be done because the charge does not remain inside the conducting sphere but moves out of its surface. An ion surface inside the sphere produces positive ions, which are accelerated away from the positive sphere to high velocities. The second application of electrostatic is xerography. Most copy machines use an electrostatic process called xerography, a word coined from the Greek word xeros for dry and graphos for writing. The heart of the process is shown in the simplified form. During the first stage, the drum should be charging. It is made of selenium on aluminum drum. In the second stage, we have the positive image made on drum. In this case, we have the number 3 reflected to the lens to cover up the charges. On the third stage, we have the toner attached to the image. The toner consists of negatively charged particles. And lastly, on the fourth stage, we have the toner pulled from drum by highly charged papers. In this case, we have the product. The third application of electrostatic is laser printer. Laser printers use the xerographic process to make high-quality image on paper, employing a laser to produce an image on a photoconducting drum as shown. In its most common application, the laser printer receives output from a computer, and it can achieve a high-quality output because of the precision with which laser light can be controlled. Many laser printers do significant information processing, such as making sophisticated letters on fonts, and in the past may have contained a computer more powerful than one, giving them the raw data to be printed. In a laser printer, a laser beam is scanned across a photoconducting drum, leaving a positively charged image. The other steps for charging the drum and transferring the image to paper are the same as in xerography. Laser light can be very precisely controlled, enabling laser printers to produce high-quality images. The fourth application of electrostatic is inkjet printers and electrostatic painting. The inkjet printer, commonly used to print computer-generated text and graphics, also employs electrostatics. A nozzle makes a fine spray of tiny ink droplets, which are then given an electrostatic charge. Once charged, the droplets can be directed using pairs of charged plates with great precision to form letters and images on paper. Inkjet printers can produce color images by using a black jet and 3 other jets with primary colors, usually cyan, magenta, and yellow, much as a color television produces color. This is more difficult with xerography, requiring multiple drums and toner. Electrostatic painting implies electrostatic charge to spray paint onto oddly shaped surfaces. Mutual repulsion of like charges causes the paint to fly away from its source. Surface tension forms droplets, which are then attracted by unlike charges on the surface to be painted. Electrostatic painting can reach hard to get to places, applying an even cut in a controlled manner. If the object is a conductor, the electric field is perpendicular to the surface, tending to bring the droplets in perpendicularly. Corners and points on conductors will receive an extra paint. Felt can similarly be applied. And another application of the electrostatic are smoke precipitator and electrostatic air cleaning. Another important application of electrostatic is found in air cleaners, both large and small. The electrostatic part of the process places excess, usually positive, charge on smoke, dust, pollen, and other particles in the air, and then passes the air to an oppositely charged grid that attracts and retains the charged particles. Large electrostatic precipitators are used industrially to remove over 99% of the particles from stacked gas emission associated with the burning of coals and oil. Home precipitators, often in conjunction with the home heating and air conditioning system, are very effective in removing pollution particles, irritants, and allergens. The schematic of an electrostatic precipitator. Air is passed through a grid of opposite charge. The first grid charges airborne particles, while the second attracts and collects them. The dramatic effect of electrostatic precipitator is seen with the absence of smoke from this power plant. Those are the applications of electrostatics. Now let's have the recap of the video. First, we discuss about the definition of electrostatics. We know that electrostatic is the study of charges that are at rest. We highlighted the 5 major applications of electrostatics, which are the following: the Van de Graaff generator, xerography, laser printers, inkjet printers and electrostatic painting, smoke precipitator, and electrostatic air cleaner. Thank you so much for watching the video. I hope you learned something today.